this is Sudheer, working as an assistant professor in Department of Civil Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. Now, today I am going to discuss you about the methods of dimensional analysis. In our previous videos, we had seen the importance of the dimensional analysis and also the dimensional homogeneity equations. And now we are going to say that there might be existing of non-dimensional equations also, non-dimensional homogeneous equations also. So in that case, what methods are suitable in order to build the relation between the given number of variables? So let us discuss what are the basic types of the variables which we are going to concentrate. So if you are going to take basically we have a very common methods like the Buckingham's pi theorem and as well as the Relics method. These are all the two most common methods which are very much essential in order to solve or in order to build the relation between the given number of variables. So here the Relics method and Buckingham pi theorem method are the methods which are most in common for the methods of dimensional analysis. So let us see a very overview about the Relics method now. Yeah, this Relics method is going to be used if the number of variables are 3. For example, if the number of variables are more than 3, then whether this may not be useful? Yes. Actually, if the number of variables are more than 3 also, this might be useful. But the thing is that the exact relationship may not be formed between the number of variables. That we are going to discuss in the next videos with the help of a small example. Now, coming to the Relics method, the basic idea of this method is to define the relationship between the given number of variables. Here the variables are again maybe a combination of the derived and as well as the secondary quantities. That is the fundamental or secondary quantities. So what does it states? If the expression is, let us assume that x is a function of variables, that is x1, x2, x3, some number of variables has been given, and in that variables, we need to identify what is the independent variable and what is the dependent variable. What is the independent variable and what is the independent variable? Then we are going to write down that in terms of x is equal to a function of x1, x2, x3 and so on, xn, where n is the number of variables that are given into your question. Now, according to this Relics method, this number of this function, that whatever we are going to consider this function, which is a combination of both the dependent and as well as the independent variables, this can be expressed as x is equal to k into x1 to the power of a, x2 to the power of b, x2 to the power of c and so on, xn to the power of n, where we can say that k is a constant and a, b, c are arbitrary powers. A, b, c are arbitrary powers. Now, it is our main aim to estimate the values of arbitrary powers. So once if you are going to estimate the values of arbitrary powers, then it is very much essential to build the relation between the dependent variable and as well as the independent variable. So this method is so simple in order to give the relation between the variables. So here the values of a, b, c are and n and so on n, that is the arbitrary values are going to be obtained. How? That is each and every term should be expressed in terms of the basic fundamental quantities like m, l, t, both on the left hand side and as well as the right hand side, and then applying the basic condition that if the base is equal, the powers are equal. Then using that principle, here we are going to equate the equations of the base of m on both the left hand side and as well as the right hand side. Similarly, the base of l values are going to be equated, and similarly the base of t values are going to be equated in such a way that we can generate 3 equations with the given type of the function. And therefore, solving as we have the values a, b, c, that is 3 variables are there and 3 equations are there, and then which can be easily solved for the values of a, b, c, which are also called as an arbitrary powers. And once if you substitute back there in the case of the arbitrary powers, then we are going to build the relation between the given number of variables. So let us see a brief overview, that is the procedure. So here what we are going to do is that we are going to express the each term of the equation in terms of MLT, that is in the terms of fundamental quantities, as we have discussed them. Next, at this stage, we need to identify what is the independent function and what is the dependent function. In most of the cases, it will be explained to you in the question that some x variable is depending upon the y, z variables and so on. Or sometimes just by looking about the parameters, it is necessary to find out the independent variable and as well as the dependent variable. So accordingly, we need to say that we need to build the relation or we need to build the function. That is, the independent function is some k into all the given variables. Just what we have seen, that x is equal to some k into x1 to the power of a, x2 to the power of b, and so on. So like that, we need to build the relation. That is, the functional statement should be written here. Now select suitable system of fundamental dimensions. That is, we are going to use here Relics method and as well as the MLT. Substitute the dimensions of physical quantities. Means whatever the quantities are there are in the given question. Already we had expressed in terms of MLT in the first step. Now those things have to be substituted in this equation. Once if the equation has been formed, then we need to say that apply the dimensional homogeneity. Means assuming that the quantities with respect to the dimensional parameters on the left hand side should be equal to the quantities with respect to the right hand side are equal. So applying the dimensional homogeneity, then equate the powers and compute the values of the exponents. Just now we have said that, for example, let us say that q is equal to AB, as we have taken the example previously. Of course, this is a well-known equation. For example, if the equation, if the question has been given like the discharge through a pipe is depending upon the pipe diameter and the velocity of the liquid particles, then we need to identify the dependent variable and as well as the independent variable. Here, dependent variable is Q, that is the discharge through the pipe, which is depending upon the area of the cross section of the pipe and as well as the velocity of the liquid particles. So here, these two are independent parameters. So therefore, we need to write down in such a way that, like for example, Q is equal to some K into a to the power of A and as well as V to the power of B. We need to write down like that. Then we need to express this equation, that is the Q, in terms of MLT. So how do you express that? That is meter cube per second. So I can express like m to the power of 0, L cube, t to the power of -1. That is meter cube per second, which is equal to some K into this A is an area of the cross section of the pipe. That is, we can say that pi by 4 d square, since most of the pipes are in circular cross section. Pi by 4 d square. Of course, pi by 4 doesn't have any dimensional parameter, and d we can express it as L square. So I can write down like m to the power of 0, then L square whole to the power of A, and as well as again t to the power of 0 and again whole to the power of t to the power of 0. That's all. Into what is V? Again meters per second. So again I am going to write down meters per second is like m to the power of 0, L to the power of 1, that is L to the power of 1, T, again T to the power of -1, again B. Now see here, all the given parameters has been expressed in terms of MLT, that is the dimension, fundamental quantities. Now we had applied the up to here, the third step it has been done. Now what we are going to do, applying the basic principle, that is, if the base is equal, the powers are going to be equal. But before that, what we need to do is that we need to arrange this equation in such a way that it is going to form only with respect to the a single m to the power of 0, L to the power of 3, t to the power of -1 is equal to some K into like again m to the power of 0, okay, L to the power of 2A plus B. Means we are going to add the powers of the exponents or the powers of the exponents of that term since the base is going to be equal, into again t to the power of minus b. T to the power of minus b. Now, if you are going to consider this equation, what happens? On the right hand side, we have mlt, and on the left hand side, we have mlt. So, therefore, we can equate as the powers of the equation with respect to the m, and then powers of the L with respect to L, and the powers of T also, since the base is going to be equal. So this is the application of the dimensional homogeneity. Now see here, whatever the quantities are there on the left hand side, they are having the same parameters on the right hand side also. For example, in any case, for example, there is another term here, temperature. There is an effect of temperature of the liquid. For example, it has been given like that. Then in that case, maybe the dimensional homogeneity may not be satisfied. So in that case, it may not be possible to equate the dimensions. So this is the concept of the dimensional homogeneity. Now, upon equating the values both on the left hand side and as well as on the right hand side with respect to m, l, t, then we are going to form three equations which is unknown of a, b, c. So basically we have three unknown values, and also we have three equations which are very much essential in order to find out the unknown values or the unknown arbitrary values. Then after that, we are going to substitute back in the above equation in order to find out the relation between the Q, A and B. So this is the example regarding the Relics method. Of course, this is a small example which we had discussed here in order for your clear understanding. Again, some more examples we are going to discuss as the time goes on. So in this manner, we are going to build the relation between the dependent and as well as the independent variables with respect to the given physical quantities. Remember here, there is no rule that physical quantities should be completely a fundamental quantity. It may be a derived quantity also. The example is that here we can see like Q is equal to K into E. Q is equal to A into V, which are always the dependent quantities. So here, like that, it is going to be useful for the case of the Relics method. As we have discussed, if the number of variables are 4, I mean that for example more than 3, then this Relics method may not be ideal to apply or to give the exact relationship between the given number of variables. Even that example also we can discuss that. So what is the method again we can apply if the number of variables are more? That is the Buckingham's pi theorem. So the Buckingham's pi theorem is the one in which it will overcome the limitations of the Relics method. The basic limitation is that the Relics method can be best applied, or it can give the result if the number of variables are equal to 3 or less than 3. If the number of variables are more than 3, then we cannot give the exact relationship between the given number of variables. So therefore, this limitation will be overcome in the case of the Buckingham's pi theorem method, which we are going to discuss in the coming on videos. Once again, I thank you very much for your kind listening to the class. Thank you. Hello everyone. This is Sudheer, working as an assistant professor in Department of Civil Engineering at Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I am going to discuss about the method of dimensional analysis. So, in the previous classes, we have discussed about the methods of dimensional analysis are of basically two types. They are Relics method and as well as the Buckingham's pi theorem. So, in the previous class, we have discussed about the Relics method and how it is helpful in order to build the relation between the given number of variables. And the basic limitation of the Relics method is that if the number of variables are exceeding or more than 3, then we cannot build an exact relationship between the given number of variables. Even though we can give the relation, but still there exists some of the unknown parameters in order to say the behavior of the or the relation between the given number of variables. Now, in order to overcome that problem, another method that is called as a Buckingham's pi theorem method has been introduced for building the exact relationship between the given number of variables, say either dependent variables or independent variables, if the number of variables are more than 3. Now, through this class, we are going to learn how to solve the or how to build the relationship between the given number of variables depending upon the question. So here, as we know that very much that the Buckingham pi theorem method is applicable more if the number of variables are more than 3. Please be clear that the number of variables, it consists of both dependent as well as the independent number of variables. So as we have discussed that in the previous classes, like fundamental or primary quantities, so therefore we can say that they are also called as an independent quantities, such as mass, length, time, temperature, etc. Then the dependent quantities are those which are dependent on the independent quantities. So for example, let us say the pressure, the pressure, acceleration, velocity, and discharge. So these are all the examples of the dependent quantities, as they are directly or indirectly depending upon those independent parameters. Now these variables consisting of both independent as well as the dependent variables. Now what does Buckingham pi theorem states that, for example, if there are n variables in a given physical phenomenon, means in the given set of question, if there are n variables and those n variable contains m variables are the basic fundamental quantities. M variables are basic fundamental quantities, and those n variables can be arranged into n minus m dimensionless groups. N minus m dimensionless groups. For example, a small example, let us say that in the given set of questions, let us say that there are 6 number of variables, which indicates either dependent or independent variables. Let us say this is n, that is n variables. Then, as we know very well that each and every term of the given quantity can be expressed in terms of m, l, t, that is the fundamental quantities. So those we are going to call it as an m variables, means each of the variable can be represented in m, l, t form, and that m is, we are going to consider it as 3. Now according to the Buckingham's pi theorem, it can be stated that these number of variables can be arranged into n minus m dimensionless groups. N minus m dimensionless groups means a constant group. N minus m constant groups can be formed, or these are also called as an pi terms. These are also called as pi terms. Now the explanation, for example, depending upon the number of variables, it has been given that if a function has been expressed in the form of the number of variables according to the given set of physical quantities, so therefore the x is a function which is depending or which is consisting of both dependent as well as the independent variables, and which can be expressed using m dimensions, that is f of pi 1, pi 2, pi 3 and so on. So these are called as a pi dimensionless groups. And again here, each pi dimension group contains, pi dimensionless group contains m plus 1 variables. M plus 1 variables means 3 plus 1 variables, because m is the fixed parameter, that is a fundamental quantities. So therefore here, according to the Buckingham's pi theorem, it can be stated that in a brief overview, for example, if there are m number of variables, which are both either dependent or independent variables, and those can be expressed in terms of m quantities, that is in mlt quantities, that is 3 quantities can be expressed, and these can be arranged into n minus m dimensionless groups, are also called as in pi terms. So here, according to our example, m minus n, that is n minus m, that is 6 minus 3, we can generate like 3 pi dimensionless groups can be formed. 3 pi dimensionless groups can be formed. So that is pi 1, pi 2, and as well as pi 3 dimensionless groups can be formed. Now it is our aim to determine the value of the pi 1, pi 2 and as well as pi 3. See here, this is not a fixed one, because here we had assumed that the given number of variables are 6. In case if the number of variables are going to increase, then the number of pi dimensionless groups may be increased depending upon the given number of quantities in the set of questions. So here, each pi term, again we are going to say that it will be consisting of m plus 1 groups or m plus 1 variables. What is m here? 3, that is, which is a constant one. 3 plus 1, which is equal to 4 variables, means in pi 1 term we have the 4 terms, and in pi2 we have the 4 terms, and in pi3 again we have the 4 terms. That is 3 plus 1 terms. What is this 3? This 3 is called as a repeating type of variables. This 3 is called as a repeating type of variables, and 1 is called non-repeating type of variable. 1 is called non-repeating type of variable. So just with this, let us see what is meant by repeating variable and what are the procedure. What is the procedure that we need to follow in order to take or in order to call it as a repeating variable. So there are some certain characteristics that needs to be satisfied for the given number of variables, because we cannot assume all the variables are repeating variables. So there are some certain characteristics which we are going to discuss now. So what is the first one is that the dependent variable should not be selected as a repeating variable. That is the basic fundamental quantity. Here we are going to see that the dependent variable. See, for example, the discharge. If you are going to say the discharge, it is a type of dependent variable. So that cannot be selected as a repeating variable. Next, repeating variables should not form a dimensionless groups. Means they should compulsory have some dimensions. They should compulsory have, or they should be compulsory expressed in terms of dimensions. In other words, we can say that if there are any constants in the given set of questions, that cannot be selected as a repeating variable. Simple. Next, repeating variables together must have the same number of fundamental dimensions. Means whatever we are going to consider the repeating variables, they must have the same number of fundamental dimensions. Then no two repeating variables should have the same dimensions. For example, whatever the dimensions we are going to take, for example, let us say that L, that is the length of the length between the 2 points, and H, that let us assume that this is the height of the liquid particles that it is going to flow. But when we are going to express the same thing in terms of the dimensions, it is having the same quantities. Like we can express like m to the power of 0, L to the power of 1, and t to the power of 0 for L, and similarly for H also, I think we can express like m to the power of 0, L to the power of 1, t to the power of 0. See here, these are going to form the same dimensions, and such kind of variables should not be selected. Next, repeating variables can be selected in any of the following methods. I mean that from any of the following properties. First one is one from the geometrical property, such as length, width, area, volume, etc. may be selected as one of the repeating variable. Then the other one is flow properties, like the velocity, acceleration, pressure, discharge, etc. may be selected as one of the repeating variable. Then fluid property, mass density, viscosity, surface tension, weight density, all these variables may be selected as repeating variables. So by following these rules and regulations, we can select the given number of repeating variables, and it should be always 3, that is m. In addition to these repeating variables, there will be another term which is a non-repeating variable. So in the previous case, as we have discussed that, let us say that there are 3 pi dimensionless groups are there. That is pi1 and as well as pi2 and as well as pi3. Terms are going to be formed according to the Buckingham's pi theorem method. So in the pi1, what we can do is that we are going to select some x1 into y1 into z1. Okay, and what is this x1? It may be either from geometric property, and y1 is might be from flow property, and z1 is might be from fluid property. Means if any of the variables, whatever they had been expressed in these properties, we can pick them as a repeating variable. But at the same time, we should see that whatever the repeating variables we are going to select, that they should not form same dimension groups. That is very, very important. And these are x1, y1, z1 is called a repeating variables. In addition to that, there will be some another term. Let us say that a is another term, that is non-repeating variable. Similarly, pi2. Let us say it is a pi2. So in the case of the pi2, we may say that x2 into y2 into z2, okay, into b. So here again, x2, y2, z2 are going to form as a repeating variables. Then next one, the last one is that pi3. That is, we can write it down like pi3 is equal to x3 into y3 into z3 into c. that is again a non-repeating variable. So like that, we are going to form the repeating variables by following these rules and regulations, and within the given set of parameters, we need to identify what are the repeating variables and what are the non-repeating variables, and therefore after this we are going to calculate the exact relationship between the given number of variables. So how to calculate the relationship between the given number of variables, which we are going to discuss in detail with the help of the problems. So here we have discussed like what is the basic use of this Buckingham's pi theorem. So it is the one advantage that we are going to overcome the basic disadvantage in the Relics method, that if the number of variables are more than 3, we can easily express the relation between those variables by using Buckingham's pi theorem. And also it is very easiest method in order to build the given relationship between the known variables or unknown variables. So with this we had completed the another method which is called as a Buckingham's pi theorem method. Thank you for your class.
Like, share and subscribe. Hit the bell icon for more updates.